Just we have to resolve the component. Here this angle is theta. This angle is theta. So this will also be theta, this angle. And here if it is theta, then there is a need to resolve the component of t and mv square upon r, both.
तो यहाँ पर थीटा कैसे होगा?
क्या?
तो यहाँ पर थीटा कैसे एंगल होगा?
बेटे this is the vertical. ये लाइन वर्टिकल है.
यस सर.
ये अगर वर्टिकल है तो this is also a vertical line.
ओके सर, कॉरस्पॉन्डिंग एंगल होगा सर.
Okay. Now see, there is, first of all you must have to decide for which we have to resolve the component and for which we don't have to resolve the component. Listen carefully. The forces which are in the direction of axes, either along the x-axis or along the y-axis, you don't have to resolve the component of those forces which are along the x-axis or y-axis. But all those forces which are not along the axes, you must have to resolve the component. So here mv square upon r and t, two forces are not along the axes, so we must have to resolve the component. Component of mv square upon r in this direction is mv square upon r sine theta. And in this direction it is mv square upon r cos theta. I hope it is clear to all. Is it clear, Vijay? Again, we have to resolve the component of tension. It is in this direction it is t cos theta, and in this direction it is t sin theta. Now, just you have to formulate the equations. See, in this direction there is mv square upon r sin theta, and this is balanced by t sin theta. All right.
Yes sir.
1 minute. Just have some confusion. Velocity is v, length is l, theta, angle is theta. Then one minute, okay. And sine can be cancelled out. We will get t is equal to mv square upon r. This situation is not right.
यहाँ पे सीधा टेंशन आ गया सर.
1 minute, okay. Just I have to see the situation. आप ट्राई करो बेटा, मैं 1 मिनट में इसको सॉल्व करता हूँ. कहीं कुछ कंफ्यूजन है. तो चाय की एक चुस्की ले लेता हूँ. mg will also act on it. T sin theta, T cos theta, mg square upon r. We will get t, that's right. Okay, तो t हमारा ये हो गया स्ट्रिंग का mv square upon r. mg will cancel out by t cos theta and t sin theta will be square mv square upon r. Yes. Okay, we can solve this question. We should have to move. See the next question. one end of the massless string, अच्छा ये string का question है, ध्यान दीजिएगा. I'm just taking a horizontal surface. This is a horizontal surface. And a spring is attached here. Normal length of the spring is 0.5 meter, is fixed, and other end is connected to a particle of mass 0.5 kg lying on the frictionless horizontal table. The spring remains horizontal if the mass is made to rotate at an angular velocity of 2 radian per second. Find the elongation in the string. See, there is a spring. Its normal length is L. Suppose it is L. And I am marking here L naught. And when it is rotated, it is stretched by a length X. Suppose this is the X stretching. Rotate करेंगे तो बाहर की तरफ force लगेगा, that will be stretched. And here the bob is rotating in this horizontal plane in this way. I'm just marking the force here. Outward force acts on it, that is mv square upon r. What is r here? L naught plus x. And another force that is acting on this, that is kx. Just clear me whether it is clear or not.
Situation is
kx is the force exerted by the spring, bete.
Okay, sir.
Force आपको ध्यान में होगा. Force exerted by the spring is kx. K is the spring constant and x is the elongation. क्या याद आया बेटे? Anyone can confirm me? मुझे नाम से पुकारना पड़ेगा. क्या ये सिचुएशन समझ में आया आपको कि दो फोर्सेस लगा है इस पे?
Yes, sir.
Why don't we consider mg here? Because the
vertically लिखा रखा है सर, horizontally लिखा है.
हाँ, तो ये horizontal plane में है तो vertical force अगर आप लगाएंगे that becomes zero because it has to be maintained in a horizontal circle. Okay, so here the equation is mv square upon L naught plus x is equal to kx. And since we have to find x, so just we have to solve for x. See, how can we solve? Find the elongation in the string. Just we have to put the values because it is easy to calculate the things by putting the values. Mass is 0.5 and angular velocity is given. See here, if angular velocity is given, then it becomes more easier. The force is m omega square r is equal to kx. And what is r? R is total length from this point to this point. And this r is m omega square L naught plus x is equal to kx. Now you can solve m omega square L naught plus m omega square x is equal to kx. Now m omega square L naught is equal to kx minus m omega square x. X can be taken as common and we can divide the remaining terms. See, k minus m omega square. This will be the answer. Tell me whether it is clear or not.
Clear, sir.
Good. Just copy it with it and be cool. Can we move to the next topic?
Yes, sir.
Good. Now the topic is banking of the road. Means on the highways, you have already observed that when there is a turn, the roads are banked. Outward it is bended up and inward it is bended down.
So, on a sharp turn.
Not only at sharp turn, even for the small curves,
Oh, sir.
it is made like this. Why it is made like this? Just we have to understand that. And when we turn the cycle or a motorcycle, you can say that bends. हम सीधे सीधे साइकिल को टर्न पे नहीं ले जा सकते हैं. क्या होता है हमें just we have to understand. The first case I am taking banking of the road. Banking. Banking of road. See, suppose there is a turn on a road and it is banked. This is the plane of the road and this is the horizontal line. This is the banking of the road. Car is moving on this. This is the car. ये इस तरफ जा रही है. Velocity is in this direction. In this way. The car is moving on this track. See, how do we deal this situation? The first thing, the force is acting. Just I am ignoring the friction because we have not studied the friction. So I am just ignoring the friction. We don't have to use here friction. After studying friction, we should include the frictional force also. Now, this is the force which is acting downward, that is mg. And since it is moving in this on this curve, so center lies on this side. It means a centrifugal force acts on this side. And a normal reaction force. Do you know the normal reaction force? Do you know the normal reaction force? Anyone can tell me, do you know the normal reaction force? First of all, see normal reaction force. Normal reaction. ये क्या होता है? See, an object is placed on a table.